Now I want us to talk about the basic rules in probability. Some of the rules to follow under probability. The first rule, we're going to bring it, maybe we're just going to collect it from the concept of us understanding elementary events rule. Elementary events rule. This is where we're going to focus our first rule from. Number one, I'm sure you can recall in the first class we had under probability, I simply defined what an elementary event is. So basically, what is happening if S in this case can be our sample space, and in the sample space we have E1, we have E2, we have E3, we have until it goes way up to N. This is our sample space, where E1, E2, E3 and En up to En are basically, these guys are basically elementary events. These are elementary events. That's what was mentioned last time. So now, since an event is a subset of a sample space, I can have E to be my event, where E can have E1, E2, E3, way up to maybe EM in this case, where M should be less than or equal to N. It should make sense. M should be less than N. Why am I simply saying so? E being an event is basically coming from the set of the sample space. So if I can collect maybe E1 and E2 to make event 1, maybe I can collect 2 and 3 to be event 2 and so forth. So it means that M can either be less than the sample space in terms of the number, or it can be equal to the sample space in terms of the number. So depending with what you are collecting. So what are we having? That information are we having under the elementary event rule? We are simply saying that the probability 0 should be less than or equal to the probability of an event I, which is 0 less than or equal to 1. That's the first thing we're supposed to understand under the elementary event rule. So the probability of maybe elementary event I happening is basically should be in between 0 and a 1. So now there are some times you're supposed to maybe to think critically, just as we emphasized in the last time lecture, to say probability is measured from 0 up to 1. So if the probability is 0, it means that there are no chances of that probability happening. If probability is 1, then it is likely, very possible that that event is going to happen. So there can never be a chance whereby probability is greater than 1. So the probability of any elementary event happening in this case, we are simply saying that it should be between our 0 and 1. That's what we're trying to say. The next thing which we're trying to understand here is that if I'm talking about the event E in this case, probability of me picking E, event E can have a certain number of elementary events. The event E can have a certain number of elementary events. Maybe E1 and E2 can form event 1. Maybe E2 and example, I can say maybe E1 can be equal to elementary event 1 and elementary event 2. This is a subset of that. Or maybe E2 can be elementary event 3 and elementary event 6. This is a subset of that. So if this is a subset of this, I'm simply saying that the probability of me picking such an event is just basically equal to probability of event 1, if this is my E, plus probability of my event 2 plus probability of my event 3 plus the addition continues until I reach probability of me having my event M. So the summation of the probability of the elementary events in the event E is equal to the probability of me having the A itself. So that's what we are trying to understand. So each elementary event, its probability summed up should give you the probability of me having this same thing. We are okay? So that is some of the information I have to understand on the elementary event rule. It is from this information now which we have to understand that if everything being summed up will give me a probability of E, it means that everything summed up, if the probability running from 0 to 1, every elementary event in this E, so I'm trying to consider this E being more like my actual outcome, where I'm now looking at this E's to be my elementary events to be my possible events which I want to come up with. So the summation of every elementary event, the probability of every elementary event in this case should basically be equal to what? A 1. So if this is the probability of having E, so each of these in here, independently, each of this probability of E1, probability of E2, probability of E3, up to probability of EM should be basically give me a summation of up to a 1. Okay? So from this information now, that's why we are looking at the second kind of rule, where we're simply talking about the complementary event rule. So under the complementary rule, what are we trying to talk about in this case? We are looking at the emphasis where we are being told we are looking at not having the event A or B, or maybe the event E. So for example, if this is the summation of, in this case, will give you a 1, then I'm simply saying that the probability of me not picking an E can be equal to the probability of picking the probability of, that is 1 minus the probability of picking an E. So under the complementary event or the complementary rule, complement rule, we are simply saying that what happens if I don't want to have, trying to refer in the relation to the sample space, because the sample space I might have a lot of E's, which are the events. So if there are several of events happening in the sample space, the probability of me picking this E, of which I know should be between 0 and 1, it means that the probability of me not picking E should basically be the 1 minus probability of me picking that E. So we're simply saying that probability of not picking E plus probability of E should be equal to a 1. That's what the complement rule should be able to emphasize on. So we have looked at 2 rules so far. We are now going into a certain part now. We're supposed to understand the additional rule. So we have to understand, we are trying to look at the theoretical aspect of it, what we mean probability when it is a complement rule or when it is an elementary event rule. We're supposed to be able to understand, because we'll dive in the questions later on where we're supposed to be able to practice through. So that is the elementary event rule, and that is the complement rule. So now, what happens, or what am I going to find in the additional rule? Because we're having more rules in this case. The additional rule, there's the multiplication rule, the partition rule, and the bias theorem rule. So we're looking at the third one now, which is the additional rule. Now, we're looking at the additional rule in this case. So how does the additional rule works for us? So simply saying that this is a rule used when considering. This is a rule used when considering that the probabilities of either of two events happening so we're trying to consider the probability of either of two events happening. So now there are cases whereby your aim is to either get probability of A or maybe either B happening. So that is your aim. What is the chance that either A or B will happen? So the chance in this case of either event A or event B happening will happen can be found by using our rule, which is called the additional rule. So now this additional rule can be solved in terms of two ways or two cases. So these two cases are, if I'm looking for the probability of A or B happening, this is just as good as probability of A plus probability of B. In this case, I can use this kind of addition principle provided that these two events, event A and event B, this should be given that A and B are mutually exclusive. So given that A and B are mutually exclusive, then the probability of A or B will be equal to probability of A plus probability of B. So I'm sure you can remember the term what mutually exclusive means. Mutually exclusive means that A and B cannot happen together, cannot occur together. They basically occur independently. This A and this B cannot occur at the same time. But in a situation whereby we have some information which is occurring in the event A and in the event B, we are being told to say the probability of A or B should now be able to give us probability of A plus probability of B minus probability of A and B. So what is happening here? This is a situation whereby A and B are not mutually exclusive, and B are not mutually exclusive. It means that there is a time which they are occurring at the same time. That's a time which they are occurring at the same time. A and B can still be written as probability of A plus probability of B minus probability of A intersection B. That's what we mean. So if A and B, there's a point in time whereby A and B are occurring at the same time, then those two are not mutually exclusive. So the addition in this case, the probability of having A or B. So be able to understand what am I talking about in this question. What is the probability of getting A or B? You are supposed to understand that basically that principle is coming from the additional rule, where these two cases can either be mutually exclusive or not mutually exclusive. So now we're looking at the other part of rule, which we're calling to the multiplication rule. Now, when you look at this case, we're looking at the kind of rule which we are using when considering probability of both events happening. So the rule used when considering both events happening. So what is the probability that both events are going to take place? That's the multiplication rule. So we're trying to consider both events happening. So if you're trying to consider both events happening, in this case, I'm simply saying that probability of A and B, probability of A and B, in this case is talking about the multiplication rule, where this is just basically probability of A multiplied by probability of B. As simple as that. So now we have to understand again that what is happening here is that there can be two cases which can be involved. In a situation whereby A and B are independent, and a situation whereby A and B are dependent. So, for example, in case 1, when we're talking about independent events. So, in example, we can say, find the probability of flipping 2 heads in a row with a fair coin. Find the probability of picking 2 heads with a fair coin. So now, the only way I can have 2 heads in this case is simply because the probability, in short, the event A and event B are basically independent. So the event A can be maybe the probability of picking a head, and the event B can be the probability of picking a tail. That's what we have to understand. So if I'm talking about find the probability of picking 2 heads with a fair coin, it means that I toss it at the first time, I toss it at the second time. That is the only way I can have 2 heads being picked. And probability of me having a head will not interfere with having the tail in the second place. Or maybe because I had head in the first place, I won't have head in the second place. That is not the case. So independent events in this case are symbolizing that they shouldn't interfere with probabilities of the other. So what does this question mean? It symbolizes that find the probability of picking H and H. So probability of picking H and H is basically a probability of H multiplied by probability of H. So we're talking about in the first toss, what was the probability of H? In the second toss, what was the probability of H? So now we're looking at a coin. Probability of picking an H is just basically favorable outcomes over the total number of outcomes. H has only one outcome over total number of outcomes is 2. In the second time again, it's still the same probability because it has not been interfered in the second tossing. It still be 1 over 2, which is equal to 1 over 4 as our probability of H and H in the first case. But in the second case, you have that you are talking about dependent events. We're talking about dependent events. What are we talking about in the dependent events? This time around, we're talking about a situation whereby because the other happened in the first place, it can't take place in second place. The first event has interfered with the second event. That's where the dependent event, I'm sure you can recall what we said under dependent event. So dependent events is a situation whereby 2 events are trying to interfere with each other. 2 events are trying to interfere with each other. So where probability of maybe B, we're trying to look at one probability provided that the other has already occurred. So in those cases, one event occurring in the first place has already interfered with the second event. That's what under dependent probability, I mean dependent events which we have. Now, what kind of example can I use in this case? We are looking at an example where we can talk about a situation whereby we have finding the probability of find the probability of drawing 2 red cards. 2 red cards in a row from a deck. So now, I'm sure we understand about cards. So we're talking about drawing 2 red cards from a deck. You pick 1 red card, again you pick a second card. So the drawing in this case, for them to be dependent events, we're talking about if I'm drawing these 2 red cards, I'll pick the first red card. So it means that the first red card when picking, that red card when I pick it in the first place, it will not be replaced back. So now, it is affecting the other event because the total outcomes has been reduced. It is affecting the other event because the total outcomes have been reduced, hence having different probabilities from the first event. We are now having different probabilities from the first event. So, for example, what I'm going to start with, I can first of all find the probability of picking the first red card. The probability of picking the first red card, you have to understand favorable outcomes. How many red cards do I have in a deck? There are about 26 red cards. Over how many total number of cards do I have? There are about 52. So if you look at the total number of cards being 52 and 26 red cards, it means the probability of me picking my first red cards in the first experiment, it will be 26 over 52. That's my first probability. But if I look at the probability of me picking my second red card, this one has been interfered because in the first place, I picked a red card. So it means that the number of cards have decreased by 1. I now have 25 cards in total. And the total cards are no longer 52, they are basically 51. So when it comes to dependent event and you're looking for the probability of A and B, this basically will be equal to probability of first red card multiplied by probability of second red cards. So I'm simply saying that probability 2 red cards will now be equal to 26 over 52 multiplied by 25 over 51. There. So the multiplication of those two will be able to give you the value or the probability of us having 2 red cards. So what have we talked about so far? We've talked about the elementary event rule, we've talked about the additional rule, we've talked about the complement rule, and we've talked about the multiplication rule. So next time when we meet, or basically physically, we can talk about the partition rule and the bias theorem, and then we can also dive into the solving of various quotients. Thank you very much and have a blessed day, night, and morning.